Before these automated workshops existed, development was a slow, manual grind. Imagine you've written your code in dozens of separate files. You'd have to manually combine them, compress every single image by hand, and painstakingly check for errors. This manual mayhem was not just tedious, it was a major bottleneck that made building complex applications incredibly difficult. The first critical job of Build Tools performs is solving the language barrier between modern code and older browsers. We write JavaScript using new, powerful features from specifications like ES6. However, older browsers don't understand this syntax. Transpilation is the process of converting this modern code into an older, universally compatible version, like ES5, ensuring your app works for everyone. The most popular tool for this is Babel.
To keep our projects organized, we write code in small, focused files called modules. This is great for maintainability. However, loading hundreds of tiny files in the browser is inefficient, as each one requires a separate network request. This is where bundling comes in. A bundler analyzes these modules and their dependencies, intelligently combining them into one or a few larger files.
Now that our code is bundled, how do we debug it? The browser sees one giant transpiled file, but we wrote it as many small, organized modules. This is where source maps become our lifeline. A source map is a special file that maps the bundled, transformed code back to your original source files. This allows you to see and debug your original, readable code directly in the browser's developer tools, making troubleshooting a breeze. With our code bundled, the next step is to make those files as small as possible. The first technique is minification. This process intelligently removes all unnecessary characters from your code without changing its functionality. This includes white space, line breaks, and comments, all things that help humans read the code but are useless to the browser. The result is a much smaller file size.
Working hand in hand with minification is a process often called uglification, which applies specifically to JavaScript. This step takes optimization further by renaming your long descriptive variable and function names to short cryptic ones like A, B, or C. While this makes the code completely unreadable to humans, it shaves off even more bytes from the file size, providing an extra performance boost.
But modern websites aren't just code. They're also images, fonts, and other media. Build tools handle these too through asset optimization. This process can automatically compress images to reduce their file size without sacrificing much quality, convert them to modern, efficient formats like WebP, and even embed small images directly into your CSS or HTML to save network requests. Every asset is fine-tuned for performance. To improve the developer experience, we can use tools that enhance standard CSS. CSS preprocessors like Sass or Less add powerful features like variables for colors, nested rules that mirror your HTML structure, and reusable blocks of code called mixins. A build tool processes this special syntax, converting it back into regular CSS that the browser can understand, making your style sheets more powerful and maintainable. After our CSS is written, we can enhance it further with post processors. A tool like PostCSS takes your standard CSS and uses plugins to transform it. The most common use case is auto-prefixing. Instead of you manually adding browser-specific prefixes like -webkit or -moz for new CSS features, a post processor automatically adds them based on which browsers you need to support, guaranteeing compatibility without the manual effort.
Beyond optimization, build tools are also our quality guardians. Code linting is the automated process of analyzing your code for programmatic and stylistic errors. A linter like ESLint can catch common mistakes, enforce a consistent coding style across your team, and identify potential bugs before your code is even run. It's like having an automated code review happening constantly as you type.
To make development truly seamless, Build Tools provide a development server. This is a local server that runs your application on your machine. More importantly, it watches for any changes you make to your files. When you save a file, it can automatically rebuild the necessary parts of your application and refresh your browser, giving you instant feedback on your changes without any manual steps. Modern dev servers take this a step further with a feature called Hot Module Replacement, or HMR. Instead of reloading the entire page when you make a change, HMR is smart enough to swap out only the specific module you edited without a full-page refresh. If you're editing a CSS style or a small component, the change appears instantly while preserving the application's current state. This makes for a lightning-fast and fluid development experience. All of these powerful tasks are orchestrated using task runners or simple scripts. Instead of running the transpiler, then the bundler, then the linter manually, we define these workflows in a configuration file. Most commonly today, this is done using scripts inside your project's package.json file. With a single command like npm run build, you can trigger the entire sequence of events, from linting to bundling to optimization. The world of build tools has evolved significantly over the years. Early tools like Grunt and Gulp were primarily task runners focused on automating individual jobs. Then, Webpack revolutionized the space by introducing a module-centric approach, treating everything as a module. More recently, tools like Parcel and Vite have emerged, prioritizing developer experience with zero configuration setups and blazing fast performance by leveraging modern browser capabilities. Let's take a closer look at Webpack, the powerful and highly configurable workhorse. It operates on concepts like entry points, loaders to process different file types, and plugins to perform tasks like minification. Its strength lies in its incredible flexibility and a massive ecosystem of loaders and plugins, making it capable of handling the most complex build requirements for large-scale applications. In contrast to Webpack's complexity, Parcel gained popularity with its zero configuration promise. You simply point Parcel at your HTML file, and it automatically figures everything out. It discovers your CSS, JavaScript, and image assets, and transpiles, bundles, and optimizes them out of the box. This makes it an excellent choice for smaller projects, prototypes, or developers who want to get started quickly without writing configuration files. The newest major player is Vite, which stands for speed. Vite's innovation is how it handles the development server. It leverages native ES modules in modern browsers, serving files directly without bundling them first. This results in a near-instant server start time and incredibly fast hot module replacement. For the final production build, it uses the highly optimized Rollup bundler, giving you the best of both worlds, lightning-fast development and a highly optimized production output.
So, which tool should you choose? It all depends on your project. For large, enterprise-level applications with complex build needs, Webpack's power and flexibility are unmatched. For a quick prototype or a smaller project where you want to avoid configuration overhead, Parcel is a fantastic choice. And for most modern applications, Vite offers an incredible balance of speed, modern features, and a great developer experience, making it a popular default choice today. Let's put it all together and look at a typical project structure. Your development work happens in a source folder, often named SRC. This is where your readable, modular code and original assets live. When you run the build command, your build tool kicks in, performs all the processing we've discussed, and places the final, optimized, and browser-ready files into a separate distribution folder, usually named dist or build. This dist folder is what you ultimately deploy to your web server. In summary, front-end build tools are absolutely essential for modern web development. They boost performance by creating smaller, optimized files. They elevate the developer experience with automation and fast feedback. They ensure code quality through linting and consistency checks. And they improve maintainability by managing complexity. Mastering these tools is a key step towards becoming a proficient and efficient front-end developer. The journey doesn't end here. The world of build tools is constantly innovating. We're seeing a new wave of tools written in faster languages like Rust and Go, promising even greater speed. As the web platform evolves with technologies like WebAssembly, build tools will adapt to integrate them seamlessly. Staying curious and keeping an eye on these trends will ensure you're always equipped to build the next generation of web experiences. Thanks for watching.